1, 2, 1, 2. Sorry, guys. Let me take it off from the top. I'll set up the volume. Up. Let me start again. All right, let's do it the right way. Oh, wait. Hello, hello, hello. Good evening, everyone. Welcome to Krhom Live, this time with a working microphone. I hope you're all doing all right. Today we have something a bit special because we'll be looking at this, which is a pair of Fatshark goggles. And I'm kind of doing it differently to how I usually do it, where people give me stuff with no strings attached, and I will prepare them and put them in the box for people to have to pick from. This was sent to me by a viewer who tried to bring them to a repair shop, couldn't get them fixed, so they're a bit out of options, and they asked me whether I wanted to have a look. I make absolutely no promises. I have no idea how those works. We're going to do general troubleshooting and see if we can figure something else. I will, however, talk a bit more about this in a moment. First, I want to do the usual updates and what's been happening and developments from previous streams. So last week we looked into this, two of those. Those are the AIOs from Newbitron, the Infinity 255 AIOs, which I have a bunch of complaining. I did a bunch of complaining about them, but yeah, this one we figured out had a bad MCU because we swapped two MCUs and then the problem moved to the broken slot. So I have ordered a spare MCU. It's only a couple bucks. I think it's like 250 euros, something like that. So it's absolutely worth spending for that kind of AIO. I haven't received it yet, but it will mean that we'll have to flash this with AM32. I haven't even looked at whether there's an available target. I had a very quick look, very quick search, and I couldn't find anything obvious, but hopefully there's a target. So I'm gonna read the other ones with AM32 configurator and see if we can figure out what it is. Because it's Newbitron, maybe there isn't a target and I can't flash it and I have to kind of find a way around it. But yeah, so it will entail flashing AM32 on the brand new chip after installation. So that's going to be interesting, and I'll try to do this on stream, prepare everything and do it on stream. I think that's a good resource to have. So yeah, and this one, that's from 2 weeks ago. This one had a cracked MCU, and those are super tiny MCUs. They're STM32F405, but it's just the die, so it's pure it's silicon die that's directly bonded to the thing. I have ordered one. I don't know if I should. They're about 10 euros, and I don't know if I'd better install it well, because the board is like, you can find this for 45 euros. So spending 10 euros on part and I'm not sure I'm going to be able to install correctly is a bit of a gamble, but it's only a 10 euro gamble, so it's not the end of the world. So yeah, that's a BGA pad, so I'm going to have to clean all of that up, remove the balls, make it all nice and tidy. There's a bunch of glue as well. So yeah, I have received the part, but I haven't done the repair yet, so I'll do that on stream as well. We'll see if we can save this board. But yeah, otherwise, I think everything else on the board works. So yeah, we need to see if we can get that fixed. So that's probably gonna be next week. But yeah, we'll see. And that's for the update. Apart from that, so those goggles. So apart from the goggles, the guy also sent me a couple of VRX. One is broken, non-broken, and one is supposed to be working. I'll show you in a second. I think he might have been killed by the goggles. But I'll show you the contraption I'm using to test them, and we'll see. But yeah, we have a bunch of people in chat already. Hey, LD Games. Hey, Biaz. Hey, Neo. Felix. Felix Simon is the person who sent me the goggles. So hello to you too. Hey, Danza, as always. And hey, Joseph. What's up? When is your stream? When am I going to watch your stream? Still waiting on that. So yeah, I'm going to be looking. And we have Grimka on chat. Hey, Grimka.
Hey.
So, hey, Louis, hello. Haven't seen you in the stream before. So yeah, the thing I'm kind of made to test this is, I don't know if you remember the junk setup I made for testing cameras. It's a screen, portable screen, I have the battery somewhere, with an AVN, and then I have an AV cable jack to RCA, and then I have a board that lets me feed 5 volts into a camera plug and feed the video signal to the screen. And if I plug a camera, it works, and I give it 5 volts on the end with my PSU. And because those are just glorified, they just generate a video signal, I can just give it 5 volts, and I remember the pins. So the bottom one is 5 volts, the pin 3 is ground, and pin 6 is video. So normally, if that worked, I think, if I'm not misunderstanding this, I should get signal. I'll show you what happens. I'm going to plug it in. I'm on 5 volts. Oh, I didn't turn on the video feed, the multimeter and everything feed. Let me turn that on now. Hopefully it will just pop up when the sources become available. Maybe if I change scenes. No, I will need to reset the sources. Multimeter. I'm not a... There's a refresh button. Yeah, that's doing it. And PSU, refresh. There we go. So you can see I'm on 5 volts. Hey, KO, thank you very much. So we're on 5 volts. I'm going to plug this in here. I'm going to turn the screen on. Let me zoom out a bit more. So the screen should display AV. After it boots. So yeah, and I'm gonna show you this. If I give it 5 volts, it does light up, it boots up, and I'm gonna grab a tiny whoop with some batteries I had around a few minutes ago. Well, here. So I have a tiny whoop and some batteries, and you can see. So turn that on. It's a bit jank, but it should do the job. And you can see here the signal is actually received. So I'm receiving mostly on that antenna because it has an antenna on it. And I'm not getting any signal here. So yeah, I don't think a signal's coming out, but I have no good way to test because I don't, my HD0 goggles, I don't have the adapter for. And I'm pretty sure it's supposed to just straight up output, but maybe there's another pin that needs to be tied to ground somehow, somewhere. So if someone in chat knows, let me know. But for now, I'm going to assume that doesn't work. But if we manage to fix the goggles if I manage to figure out what's wrong with them, and I'll stick that into it and see if that works. But if it doesn't, I won't assume it's broken. So yeah, let's turn all of that off and start opening those goggles. So interesting thing about the goggles. I did plug them in, and I did give them 4S. I'm pretty sure they are 4S compliant. The screen's turned on, and I had a gray image. And I think the issue is just with the receiver. That's what I've been told. But it started stinking. Or maybe it was stinking before, but it smells of burnt electronics. So yeah, we should see something. And if we don't, we'll see it on thermal cam immediately. But yeah, right now it just stinks. It stinks exactly like when you burn your flight controller.
Would you mind activating your stream on Discord, please?
Oh, the stream on Discord, yes. Yeah, I was a bit late
you.
today, so sorry. Doing that. Now, for those, that leads me to, if you want to follow the stream with a tiny bit less latency and want to chat on voice, you're absolutely welcome to join the Discord and join the voice chat. As long as you don't just talk all the time and stop me from telling you about repair stuff, there's absolutely no problem. If you want to ask questions while I'm working on Microscope, just general chat, then you're absolutely welcome to do so. And should be good on Discord. Okay, let's back that up and we'll see. We'll start opening up the goals. What do we need for those? That's just, yeah, I think that's just a Phillips head. Might need a deeper Phillips head. Actually, that might be annoying because I don't have anything that goes very deep at hand. This one, now it works. Yeah, might need. Is that? Yeah, I'm gonna need something that goes deeper here. That sucks because what I have here, it has something. I'm gonna have to go downstairs, or maybe I have some screwdrivers. Oh yeah, I do. Hey, I do have some things. Sometimes it's not very. It's like the cheapo screwdrivers you can think of, but they do unscrew. Don't really unscrew well. They do unscrew stuff. So we have 3 screws here. Do we need more? So let's see if we can remove this. Yeah, that can be removed. Has a plug. Okay. Let's see where do we get? Oh, faceplate probably needs to come off. Yeah, that's exactly what Felix is saying. Need to remove the faceplate. And it's a bit weird because the fan is part of the faceplate. Trying to do my best not to damage anything. I have to click it back in. There we go. So this is not a fan. It's purely decorative, apparently. And this is also where you can put your 2S battery balance lead. So now we have not lost 3 of the screws. Let me grab a small box and put the screws in it and not lose them. Right, now we have, so that's coming apart. I think it should be coming apart altogether. Those are very light goggles. I'm not expecting to find a billion electronics inside, but just I want to be very careful and not damage this any more than I have to. Yep. Hey, Daniel. There we go. So we have an optical module. We have a, okay, that's quite a bit. That's quite a bit in there. This is probably where the stinkiness is. I'm pretty sure. Let's see if we can take this apart and disconnect things. So there's one thing here we can disconnect. Do I have plastic tweezers? No, I'll go into ceramic. Try to open that up. So I need to make sure I don't mess anything up. So these connectors, you pull back, and then you can supposedly just pull the connector out. There you go. This can be pulled off. Okay, so I have to think that I need to figure out what's stinky and what it's supposed to do, because there is stuff in there. There's stuff in there. Hey, Shax. But oof, yeah, the stink comes from here, which, from what I understand, I feel like the cable is not looking its best to start with, but regardless, okay. It's gonna be a bit annoying because I don't have a good way to power this board on its own. I think that's just the on-off button for this thing is just the on-off button to power this. And let's see if we can figure out what this is. But yeah, I would like to be able to power this up directly just on its own. So I might have to kind of figure out where the power is coming from and see if we can turn it on. Because ideally, I'd like to be able, if it's fixed, to put the VTX here, the right way around, and the VRX, and power the VRX and see it light up and everything looking good. And I'm quite surprised because it does stink a lot, but there's nothing completely broken. So let's put it under the microscope and see what we can see. Let's have a look. Actually, I'm gonna remove the ribbon cable completely, so don't run the risk of damaging it. Okay, so let's focus up. And yeah, you are also in focus, that's good. Okay, so this looks like a FAT. I mean, it doesn't have to be, but it kind of looks like a FAT. Could be power management. Can't see anything obviously broken. We're gonna start having a look at whether caps are shorted. This, I mean, is this the thing getting super hot? Let's see if we can clean it up and read it. Let's go for a Q-tip. Is this the thing getting super hot? I don't know. Could be. It has a big line on it, which I know, I think I heard from Felix that he did have a chip replaced. I don't know if that's the one. He might let me know in the chat. But do we get a reading? With the polarization we do. I mean, don't know what that thing is. CH7. Yeah, I don't know what that chip is. Let me orient it well, grab a screenshot, and ask Gemini to identify it. Maybe it will. I don't know. I'll grab a quick screenshot and just quickly off screen, I'm kicking it off and telling it to identify this. Okay, what else? So we get a bunch of diodes here. Is this burnt? No, not necessarily. It's all the... Is that HDMI? HDMI port. There's a missing resistor, but probably it's factory. This might have been the thing that went hot because of the... Can see it being kind of... If it had been changed and put the wrong way around, we'll test it. I just want to do the inspection of the other side, and then we can try to start probing with the meter. Okay. What do we have here? That has flux on it. Oh, that's the part that's been swapped. Could have been put backwards, which would also mean lots of heat and disconnection. What's this? Why is this peeled here? Coil has this weird thingy. Bunch of diodes. I don't know exactly. I never knew what those diodes are supposed to do. Those big, I think they're diodes, orange things. But we'll test them. And yeah, is that a crack in the cap? Nope. All right, so let's start poking. We'll go for first a bunch of continuity checks on some capacitors. So yeah, I don't know. This could be. Do we have this? Is this part of a BEC? I don't know. Usually, I mean, in my experience, coils are parts of. I don't know what that's supposed to be. In my experience, coils are part of BEC circuitry. I can't see where the BEC would be. That's ground. It's between ground and something, so it might not be. It might just be some kind of filtering. So let's see if we can see some obvious shorted cap to start with. We'll do a quick check for that. I would save. That's supposed to be, I don't know, just a big resistor. Don't know what it's supposed to do. This should short, that's a fuse. Well, it is shorted, so it is supposed to beep. It does. It makes me realize that I need to kind of wiggle my, there's some kind of oxidation on the things, so I'm gonna have to wiggle my probes to make sure I break the oxidation, so I can catch a short. Do we have some kind of marking on the board that could kind of help us know? So this is a diode, so we can go to diode mode and test the diodes actually. So because we have the markings here on the front, that means the current goes from there to there. So my red probe needs to go here. That's 11 volts of voltage drop, and that's 13 volts of voltage drop. Okay, that diode is cooked. There's no diode that should have a 11 drop in one way, but also an 11 drop and 13 drop in the other way, unless there's some other thing happening around it. That could very well be a TVS diode. That's there to protect from reverse polarity, and I think it might have been put on backwards. Makes me want to remove it just to see. I'll probably remove it anyway, just to see, but some other caps we can try. I mean, that would... Oh, I'm still in diode mode. Let's actually go back to diode mode and see if those big yellow things are indeed diodes. Still, so that would be red, that side. Yeah, so we have a voltage drop of 0.46, so there's some form of diode, I'm guessing. So I'm gonna, why is it 1.6 volt drop? That's not normal. And what happens if I go the other way? Should be 0. Yeah, that's 0, okay. Can we have 1.6 voltage drop? Does that make sense? Okay, that's not a lot. Yeah, that must be on the same line as this. So it's going through. Yeah. Yeah, I'm reading the same. I'm reading the same as exactly as this one. So I'm guessing the same circuit and it's just going through this or through something else that's doing the beeping. I don't know. I don't know what I'm doing. So we'll go and inspect the other side for shorts and caps. See if we can see something strange. Let's go back to continuity mode. Hello, Alexis. Okay, what do we have here? Big cap. Are you shorted? Okay. Oh, do you think this guy has a problem? What do you think, guys? Does it have a problem? I think it does. Okay, so that's the back that matches the coil. And there's some trace repair that he's doing. Okay, so I'm gonna have to switch that out. I don't have a spare, so it's BQGK, I think. It's gonna be, is it BOGK or BQGK? I think it's BQGK. So yeah, that's what burnt. And we can repair that, that's not a problem. I'm gonna cut the trace before it starts going back more. Okay, but yeah, if we can figure out what's the output and what it's supposed to be, I can just inject the voltage and see if we get stuff turn on. But usually they will have input and output on this side. I think that's the output. So let's see if we can figure it out. So usually ground will be the big thing that's all over the place. Can we get a confirmation what is ground? So ground is going to be, the HDMI is going to be ground. I'm guessing one of, okay, middle pin is ground. And you can see, so we kind of have to somewhat reverse engineer how this works, because if you want to fix it. So this, you can see this pin is tied here to this big plane. So big plane is ground, and this is ground. So if we get, the question is whether we have a short between ground and output and input. And we have a kilo ohm between, which I assume is the input here, and how much between here and the output? And nothing, open line. So we don't have a shorted component, that's good. BQGK, let's have a look. Let's have a look at what Gemini told us for the other chip, and we'll search BQGK. JK? GK? JK, BQJK. Hello, Clem. So this chip, what Gemini, so Gemini is super useful when it comes to identify chips, but sometimes it gets it very wrong as well. So you always have to double check the datasheet. Krhom tell part number, what does? HDMI to CVBS. That makes sense. That would be for HDMI in. So that's the thing that takes the HDMI into video signal. So yeah, that makes sense. Thank you. And then now I have a Beck IC Mark BQJS. It's a SOT 23-5. So that's the type of package. SOT 23 is those kind of rectangular thing with legs on both sides, and 5 is because it has 5 legs. Can you there we go. We'll let it do its thing. I'll remove the part. Might as well. Have to remove it anyway. But I don't know if that's the only issue we have on our circuit. Probably isn't, but that's definitely one. By getting the data sheet, I'll be able to see which pin is which. Something I want to try actually. I have recently gotten a new thing, a new tool. And let me show you the tool. I've been watching a bunch of what's-it-call-it, Northridge Fix, which is a repair channel on YouTube, a big one. They've been there for a while. And he often uses on those boards where he doesn't want to run the risk of damaging stuff around, like we have a big connector next to it, which is plastic. He uses low melt solder. And this is special solder. It's made of bismuth and something else. And it melts at ATC. So if I alloy it with the solder on the board, I should be able to just pull the chip. Just the solder doesn't solidify, basically. So I'm gonna give that a try. A feat. I've never used it before, but I mean, it doesn't look very complicated. So I'm gonna put a fine tip on my iron, and we're gonna give that a go. So the idea is that just put a bunch of it on all the pads, and then the whole chip should come free. It might come with my iron, actually. It wasn't super easy to find this stuff, actually. Let's see if we can put some more. Might need a bunch of flux, actually. But yeah, you can get it. I mean, it's not hard to find. You just need to get. You can't. I couldn't find some on AliExpress, for example. I had to get it from DigiKey. When I made an order recently from DigiKey, so I just added this. It ain't cheap, but it should last me for a while. Let's see if we can. Is that solidified? It has solidified. Let's see if we can reuse this big fish here on the left. There we go. Look at that. Convenient. Now I just need to clean it up. The whole thing stinks. I mean, not the solder, but the board stinks. So yeah, easy. That works. I think that's a very valuable tool. Let me clean that up. I'll wick it up now. I mean, I'll probably just remove this bit. And grab a wick. I think I have some leftover wick. Yeah, I do. Grab the wick. So you need to make sure you get rid of all of it. Obviously, you don't want your stuff go, your components to go away at 80 degrees. Though I did suggest you might want to make a hard mode ESC where you solder all the FETs with this. And if your ESC goes over 80 degrees, the whole thing disorders itself. So it's a challenge ESC. You have to fly super smooth. When I say tool, you hear toy. Tool, toy. Yeah, I don't know. That's in your head, man. So yeah, that's all clean. A bit of my magic cubes. Where's my magic tube tweezers? There we go. So this will need a replacement, but I want to make sure. Let's see if we can check what trace is what. Let's go to our Gemini has had an error. He wants me to ask again. I'm gonna ask again and not bore you with the details. Okay, so thing is, I do have a bunch of those very similar FETs, but I need to reboot Gemini. It's unhappy. It's been quite slow today. It's been quite slow today. I can't even copy paste the code, the text. It's awful. I could technically Google it, but you know, who wants to Google where you can just have the robots do it for you? It's not actually easy. The reason it's not always easy to identify chips is because the markings on the chips don't all refer to the chip itself, which one it is. Usually you have some of the markings are referred to the chip, some of them refer to the year of manufacture or batch number and everything. So I think it's fine. Something it suggests this thing. Let's see if the datasheet seems to match. What is it suggesting it is? High efficiency voltage regulator or battery management IC. Voltage regulator most likely, not battery management IC. It would be an LDO. I'm not sure. Let's see if the datasheet seems to match. Which can I? Yes. Can I get rid of the dark mode, please? Sometimes you don't want dark mode. Okay, so does it looks like the right package at least. Let's see if we can find, so to confirm it's the right chip, we're gonna look for the section that tells you about what's marked on the chip. It should have a top markings. Yeah, so top markings, is it symbol? So we said it was the A. Oh, I removed it. I should have a pic somewhere. I have it written. It's BQJS. Does that match something? So it would be B, then 2 and 3. Yeah, I'm not sure. That's the ordering information. That's not the top marking. They have a section for top marking. Top marking. Oh, and it's a very dense data sheet. I don't think it matters too much because I feel like, from what I've seen, they almost all have the same layout. So that's not this multiple variants. We want a variance that looks like this. So out. No, actually, no. They don't, because the ones I've seen have in and out on both sides here. So if we trust this one, this would be not connected, in, out, inline. Let's see on microscope. So this would be in, and this would be out. I mean, fair enough, it could very well be. Do we have, the question is, do we have, why does this, is there a via under here? That's a good question number one. Let's see if we can cut, I'll cut the trace. Because, I mean, if this was continuous, then it's obviously not this chip. Because that would be tidying up the out and in. Let's clean it up a bit. We can't really tell. We can by just looking at the other side, because I think that's just a dual layer board. Can we see actually? Let's have a look at the side of the board. See if we can tell whether it's just a dual-sided board. If you can see some copper in it. It might not be clear. Yeah, it's not absolutely obvious whether those lines are copper or not. It could be that top layer, then mid layer. It could be a 4-layer board. Let's see if we can grind away at it and reveal some copper. Trying to understand what we're dealing with. Is that enough? I mean, I don't want to damage anything, obviously, but I don't think there's enough to say. I don't know. Could be just the fiberglass material. I don't know. But regardless, if there's a via here, it will be on the other side, the vias they go through. And so that's this one goes here, and there doesn't seem to be any other via. Can locate with respect to those dots too. And we are, where are we? Here. So it's just, yeah, so that's opposite the dot here. Yeah, it is. So yeah, there's no other via in the middle, so we're fine. So it could still be that chip. I don't know. But let's see if we can kind of figure stuff out by tracing, trying to understand the traces. So I'm expecting, because this board is being powered through a ribbon cable, that the input should match one of the pins on the ribbon cable. So this should match one of the pins here. Okay, and it doesn't, so could be that it's through a diode though. So I'll go to diode mode and put my black probe here and see if we can get a beep through a diode. No. If not, we'll see if we can trace the... Oh, but no, I know, but that has to be the wrong chip. That has to be... Now I think about it. Look, this pad is tied up to nothing. This pad is tied to ground. This pad is tied to something. This pad is tied to something. This pad is tied to something. This is tied to nothing. And I'm guessing this was a single trace here. So it must not be the chip we saw. AI got it wrong, which is not unexpected when it comes to small markings like this. And we have ground here. We have something here, and something here. And this must have been one continuous pad. I'm guessing that's a non-connected pad, but it could be tied to here. I mean, the trace going here kind of makes me think it has to be going all the way there. So we'll have to put a pad back here and find the chip. But we are back to trying to figure out which one is in. And it's going to be tied to something around here. So, there we go. So that's the voltage drop of 0.2. So that's through a diode. Them here. Okay, so all of them. So it might be related to the bad diode we got, so we don't have much information. I really want to remove the diode on the other side. But I'd like to know if this is also tied to something. The other thing I could do is power the goggles with the... I broke my thing. Power the goggles with the with that board unplugged and probe the wire, the ribbon cable, to kind of try to understand what's coming through. Hey, Big Mama. Hey, CMYK. We are looking at a board from Fatshark goggles, and something's burnt, and we're trying to understand how it's made, basically. So, this is probably a coil, actually. Is it? Guessing it's a coil. Yeah, that's probably a coil, so that's probably a back. That's probably another coil. I'm guessing that's another coil. I mean, that's absolutely dead shorted, so it must be a coil. Let's go to continuity in a diode. Yeah, so they're coils, though they're supposed to be shorted. And okay, so the on button, oh, that's also gotten hot. So the on button connects. Is this? Does it look like it has a correct value? 480, 470K. Oh, ohm, 470 ohm. That sounds like, I'm not sure. I'm not sure, but that got hot for sure. You can see the thing. So yeah, I don't really know yet what. I want to remove the diode on the other side because it feels to me like it's been. I mean, I can always put it back, but it's been removed before, and from what Felix told me, there was some amount of some shop replaced parts for him, so we'll see if we can understand what it's for. Let's do it the same way, actually. Let's remove it with a low melt. Let me grab my stick, put some flux. And we'll try try to alloy the shit out of this. There we go. It's nicely alloyed. Now just need to alloy the other side. Let's try to not alloy everything with it. Try to push it away from. I mean, it shouldn't melt it anyway. There we go. And now we should be able to just pick it up. Pick it up. Pick it up. There we go. So let's see if we have a. We'll measure it off circuit. I'm gonna suck up those. I think that's gonna be. Yeah, I'm gonna suck it up with a wick. I'm really loving this low melt stuff for those boards. That is very convenient. Felix, I can't give you a recap in French, but I can give you a slow recap in English, and hopefully you'll get it. I don't want to start mixing languages in the middle of the stream as much as I can, but basically we found a dead chip, a voltage regulator on the other side. We removed it. I'm trying to understand what's what. Basically, what is going where, what's the output of the regulator, what's input, try to analyze. And this diode here was kind of, since it's been replaced, I wanted to remove it and kind of analyze without it on the board. Try to see if it was put on backwards or blew up or something. Okay, all good. I'd like to remind you all that I have no idea what I'm doing. I'm just trying to figure it out with logic, and hopefully it works. So yeah, this doesn't tell you what direction the diode is supposed to be. I think it's supposed to be in the direction it was on. Can we see from the legs? No, the legs don't tell you. Okay. Okay. Yeah, it's between ground and the output of the coil. So is it a TVS? It's possibly a TVS diode, so it might just be not necessary for the circuit to function. But I don't know. I do not know. Let's see if we can measure. We still measure the diode mode in both ways, which is not something we want and something we did measure on the pan. So we were getting 1.1 and 1.3 volts either way, voltage drop. We are no longer getting that. So I'm guessing the diode, which we're going to test on its own, is doing weird things. It's not. Huh. Maybe. So that's 1.6. And the other way around is doing nothing. Why was I getting bad readings? So I'm guessing it is indeed a TVS diode, or some form of Schottky diode. Yeah, I don't know. I was getting low voltage drop here through the TVS diode, probably. Was it then in the wrong orientation? I don't know. I do not know. We might have to go and look for photos of this board to make sure. And this cap sure looks cracked, but it isn't. It really does, though. Okay, so something we can do is, I do have a known fact. I know which pin is supposed to be 5 volts on the VTX. So let me see which direction it is. So this goes in this way. So, and this goes in this way. So this bottom pin is 5 volts. So this bottom pin here. So you can see, so we see you can trace down the 5 volt circuitry and try to take it from there. So 5 volt is this guy. It is kind of discolored, probably because it got hot. There was supposed to be a component here. There's no component here. A cap, C8, a big cap. If Felix, if you remember, if there was a big cap here, because those don't look factory. Those look not factory. I mean, it would be a big filter cap, so it doesn't matter too much. But that's between 5 volts. Maybe. So let's see if we can trace this 5 volt to other points. Let's go back to continuity mode. Okay, so 5 volts here. Do we have test point for 5 volts on the right? Don't know what those holes are. There's also something that went here. At some point, it's... yeah, I don't know. But this might have in factory, so I don't know if it's just not there, not populated. This as well. It's hard to say. Yeah, I don't know what those are. Can we link the 5 volts to something on the other side? Actually, can we link it up? So so 5 volt is here. This guy here. Is it just this big plane that goes on here? I mean, that would explain. This would switch to 5 volts. Let's see if it's continuous, actually, the switch. Let's see if it's continuous to 5 volts. So if we go in here, I'm hoping I'm making good contact. Yep. Well, yeah, I think that's supposed to be continuous a fuse, but not sure. But it definitely is not. Is that? Where is that going? So where is that going? We're going to go on the other side of the switch. That is a fuse. So it comes from here. It goes. Wait. That goes here through those vias. Let me zoom in on this fuse, see if we can understand. Yeah, so that big vertical trace is all 5 volts. Okay. And where does it go next? It goes through here, so that's still 5 volts. That's part of the same pad. 5 volts, there's some diode that goes from ground to 5 volts. That would be a reverse current, a reverse voltage diode, protection diode, I'm guessing. Let's see if we can figure out what this goes to on the other side. It goes to those vias, okay. They don't do anything. And the bottom part. So because that's ground. And it's all very hard to to figure out. Let's see if we can get a contact between this side and one of the pads here. We don't. The other side maybe. So moving on to the other side because we know it's... No. Where is the 5 volt coming from? Could be that this generates the 5 volts. Could be. Let's see. This is ground. Okay, so this is ground. Okay, let's look up this chip. See if we can find it. See what it does. Let's get a good photo. See if we can understand what it is. Yeah, I can't see anything obviously broken, so it kind of sucks that I have to go through the understanding. It's going to take a while, but let's ask Jenny. Let's see if it can sort it. So, it was quick this time. Okay, so it's DC-DC boost voltage regulator. Okay. Let's see if we can find the maging. Maybe it can find the data sheet and we can confirm that this one is indeed the right one. Yeah, so it's a Chinese thing, so it's going to be Chinese. Let's see if we can see something that's not the right chip. That is not the right chip. Is it? Could it be that it's just, oh, it's not like, so it is possibly the right chip. Is it 4 legs on my photo? Why don't you have the photo? You can just go to Microscope. Yeah, it's 5 legs on each side, so it's definitely not this. Guessing it just got, oh, that's 5. Doesn't look like the right shape though. So yeah, it could be, it's square. Can we get data sheets? No, I do not want a fast code. Data sheet. Data sheet somewhere. No data sheet. No data sheet? Information. I guess no data sheet. I mean, it did say that it doesn't have data sheet. The link is not clickable. Thank you, data sheet. Okay. I love it when we can't know what the... So yeah, it says it's compatible with this thing, but is this thing not even the right number of pins? So it's not compatible. Okay, so it's probably some kind of boost converter or something. Can we... Oh, actually, I wanted to check. Do we still have the weirdness happening on the... when I was trying to figure out the continuity between one of the pads of the burn chip and here, and we were having a... I was in actually diode mode. I think we might have to go and read the... Oops. Okay, so now it's reading a diode drop of 0.5. If only I could get a good idea of what power rails were what. Okay, so is this, what is this part? Like that got hot. Is that a resistor or is it a filtering coil? It's gray, so it could just be a coil, and in which case, oh, it is super low drop, is it? What's the resistance already? This could be just a ferrite bead, basically. It is 500 ohms. Yeah, yep. I don't know. I would need to start drawing the schematic, I guess. Maybe we just plug it in and read the voltages. I'm pretty sure it's now safe to plug it in. I think we're gonna have to start plugging it in anyway because I don't have much more that I can try otherwise. Try to not damage this. Can we get formation? So if I look at, let's try to get a bit of an understanding of how it all works. So that's where the power comes from the jack. There's a big regulator, and that power that goes to, so I don't know what this big regulator does. Can we get a, yeah, I don't know what it does. Then that goes to the main board, which is here. Now we have all the optics stuff, the main board with the OS. There's a big coil here for regulation, I assume. It has the shape of a coil, but it has a bunch of traces going to it, so it's really not a coil. That's a coil. An inductor. What I can do is put it back together without the sideboard to confirm. I turn it on to confirm everything's working. I'm drawing a normal amount. I'm getting response from the buttons, and just to make sure everything else is working okay. I'll do that first. So, just gonna put this back, kind of just junkily. It's off now. I'm gonna use my, I need to redo this. I managed to break my wire. Oh, that sucks. Well, we have a side quest. You're saying there was something that burned on the input board, Felix, like the one on the side. Is that what you're saying? Let's see. Can I see? I can't see repairs being done on this side. Okay. But let's have a look. I'll give it a little bit of power with overcurrent protection and everything. But first I need to fix this, which I managed to break because my probe wires are stupidly thin. Oh yeah, remember I need to make new probe wires that are not ridiculously thin. But for now, I'm just going to have to do this quickly. So, side quest. Yeah, that's what happens when you buy cheap stuff from AliExpress. Sometimes you get crappy stuff. I'll need to remake the whole thing with a proper big AWG wires, but I'm going to just quickly fix it for now. Let's go a bit further down. So we tend to have, look at this, like look how little conductors there are in this wire. It's like, all crust, no meat. Cheap, cheap, cheap. Almost killed it, but yeah, that's very little. Very little to go here. Nice solder. Oh, is this one of those that are... I actually told that to a friend yesterday, but those cheaper wires, if you don't know, sometimes they're actually not only is there not much conductor, but not even copper. The way you can test is by using a magnet and see if it's attracted. I don't think this one is. Yeah, so at least it is. Hey, Olivier. Yep. I am doing my best at trying to understand how Fatshark goggles work, but I am very much out of my depth, especially since the components are very hard to identify and don't necessarily have data sheets. But I might not figure it out today, but I will figure it out at some point. But yeah, okay, so I'm gonna give it some amount of juice. I'm gonna go for, I think they can take 2S. Yeah, I'm pretty sure they can take 2S. So I'm gonna go for some 2S voltage. And let's go for 8 volts. And I have overcurrent protection. I just want to check if there's something abnormal in the power it draws. How you need to take care of a DVR board of your own. Yeah. So I'm getting 0 because the things are turned off. Let's turn them on. I'm expecting maybe a few watts. 2 watts, it kind of took a while to go up. 2 watts sounds reasonable. I have a picture. Okay, and nothing's smelling bad, so that sounds reasonable. Let's see. That's all very reasonable, I think. And yeah, I don't know what that board is supposed to do, but what I can do now is start probing on the, try to be super, not to break the ribbon cable that goes to the screens. I can start probing on the connector. I'm gonna need to go to the scope with the contraption, and I kind of start. I want to see what's what on this rail, because I'm guessing there's some voltages coming through. I mean, it has to be. There's no other way. All right, so first, let's look continuity. So let me show you the microscope. And I'll need to figure out which is ground, which part is ground, but it should be fairly easy. And okay, so I can just go, this should be grounded. Maybe it's not, but is this grounded? Huh. I mean, one of those two things isn't grounded. This is probably, yeah, those two are going to be ground. Oh no, this is ground. You can see the big ground plane here. Is this tied to anything? Can I find a definite ground somewhere? I'm looking on the board. I mean, I can just, actually, I should get a definite ground. I'm touching the barrel jack on the goggles part on, actually. Yeah, there are. I'm touching the barrel jack of the power plug, and I'm trying to see if I can find the ground. But looks like it's not connected. That's weird. But I mean, those traces are tiny. Has to be either this, which is a big ground plane, which I expect it is. It has to be this third one. Does it match what we see? Actually, first of all, is the ribbon cable 1-to-1? I'm guessing it is. Yeah, so let's see if we can match this to the other board. Yeah, so we got on the other board, we also have two pins together, and then one that goes to a big plane, which I believe is our ground, which is this guy. Yeah. Okay, so our ground is here, so I'll be able to read some voltages off the ground. What's wrong with them? Asked you. The board with the where you put in the VRX, it has burned down. There's something that looks like either an LDO or an LDO probably has burnt out. And I'm trying to understand how it works, so I know whether it's just the chip that went bad or whether something's shorted down there. And I'm very much confronted to my lack of knowledge about what components do in some places. So I'm kind of trying to go one step at a time and try to understand. And right now I want to understand what's coming through to that board. And I want to know what voltage it receives, basically. So I'm going to power this up and read voltages here and see. They have a switcher on that board besides power supplies. What do you mean a switcher? Oh yeah, it's to switch the HDMI or VRX input, because there's I found the HDMI to component plug. Okay, I'm giving it some juice. Yes. And I'll probe voltage mode, DC volts. So I want to, this here. So that's 7.5 volts. So that's VBAT minus a diode, I'm guessing. And I don't see any of the other one being anything that's voltage related. So if I go and check this. Oh, there it is, kind of. Maybe it's a signal because it going down. Don't know. Yeah, it's probably not a real voltage. It goes down, so it's probably some kind of signal. So yeah, we know where the voltage comes in, and it comes in as for VBAT basically. So we can go back armed with that knowledge and try to trace the thing. Maybe we'll, I mean, if we can figure out what voltage that regulator is supposed to be, then we can try injecting voltages. Okay, yeah, I can, that's very interestingly viewed. There's a bunch of inductors, for sure. I've noticed that, but I don't really, I guess knowing that there's a switcher, I can try to understand what that is and how that works. But if we go back to, so first of all, since you're here, Liv, can you by any chance confirm to me that those big orange things are indeed diodes? There's a bunch of them, and to me they look like reverse polarity protection diodes, but why so many? Yeah, that would be nice if you could confirm that. But we know now that VBAT is coming from here, those two pins, and ground is next. So do we have a, I'm not in continuity anymore, let's go back to continuity. And do we have continuity from this to one of the pads? We do not. Do we have continuity to one of our pads, but through a diode? That's the question. Let's go to diode mode. Ah, we do. Oh, it was continuous, I just didn't probe it correctly. So, let me check, but I think I just didn't probe it correctly. So this is our input, this is our VBAT, so this is our output. And now we have a ground, and we have a whatever chip, pin. I don't know what this pin does. Where does it go? Let's see if we can find where it goes. So it does via to a, it's aligned with this. And it goes to a coil. Also, it is a back. I guess it is a back. Maybe there's a big coil here that seems to go. Let me probe actually. So it's hard to figure out from which side which is what, but I believe this is where that pin goes. Also, look, there's some there is some heat that got in that pad, which makes sense. This stuff got hot, but yeah, so it is. So it is tied to that coil, so maybe it is a back. I don't know why those big blobs are though. Those are weird. Big blobs. Actual, there's a switch, there's an actual literal switch on the board to turn off the VRX. Grab a bit of water. Okay. Can we conclude anything? It would be good to be able to find the bubble. So the output. Oh, actually, I think I kind of understand. So the output is like diagonal next to the edge. So that's the output. Okay. So there's, of the two legs of the component, one goes here and one goes there. And there. That's a transistor. I don't know what it transists, but it is in between this and this. It goes back. I don't know what the schematic for this part is. It's all part of the Beck circuitry. So I'm guessing this is supposed to convert to 5 volts. I would say probably. Can't be sure. Can't be sure. But can I expect it's 5 volts because that's what we want for what we need for the VRX. Let's see if we can trace around. If I can trace around to the 5 volt pin, to this. So the 5 volt pin is this one here. If I can find a route in some way, diode mode maybe, then I can just inject 5 volts to it, but there's no path. No path. Is it turned on though? It wasn't turned on. There is a path. Okay, so if I inject 5 volts to the thing, I should be able to get the thing to turn on, and we can see. Let's see if we get a. So we want to see if there's a good reason not to give 5 volts, to send 5 volts to the pin. For that, we'll see if we can get a. Yeah, we get a massive resistance to ground. So if we put 5 volts on it, we won't get anything bad, supposedly. So what I can do is grab a LiPo to power the goggles and try to inject. Actually, we can start by trying to inject 5 volts onto this, so I can solder. Oh, by the way, we can see the signals and stuff like that. I think it's talking about it. So that's 5 volts. That's the ground pin, but they're all pulled to ground. And pin 6 is supposed to be the signal. On this side, it's not doing anything. On this, there's a pin 5 that's pulled somewhere. Is it pulled to ground? It's pulled to ground through some resistors. So that might be why I'm not getting any picture from the other thing. Maybe this pin needs to be pulled down. Yeah, that's... Okay, what's the resistance between pin 5 and ground? So pin 5 overload. Are those not resistors? So that's good. Oh, 10K, I just wasn't pushing hard enough. Okay, so there's a 6K pull down, some kind of pull down with some filtration on this pin. Might be the, I don't know, might be the audio pin. And what's this connected to? Okay, so that's the video. Just trying to trace down the video where it goes. So that's pin 6. So 1, 2, 3, 4, 5, 6. So that's this trace, and it goes straight to here. So what I want to do, actually, I want to try feeding a video signal to the to the goggles without using the VRX. I want to use a camera to feed it a video signal. So first, I'm gonna need to solder a 5-volt and a ground pad and a signal. I'm gonna solder 3 wires to 5-volt 5-volt ground and VTX. And I can start. Basically, I want to see if the goggles receive a signal. I get a display in the screen, and I mean, if it's a video signal, I can send any video signal. I'm gonna send any random video signal, and for that, I'm just gonna use a camera because I don't know if I can trust the VRX, but I'm pretty sure. The only thing that this board needs to do is output video. So let's cut some wires. Let's tin some wires. Okay, sure. Yep. When you're not sure what to do, just start doing things and hope it goes well. Basically, we'll move backwards and see up where we can get it to work. So first, like by putting 5 volts on that board, I'll be able to know if it seems to be like shorting somewhere, something gets hot or anything, or if it seems to be okay. And then, so the hard part is going to be a hard part. I don't have 2 PSUs, so I'm going to have to. Actually, I do have 2 PSUs. Will give me a good opportunity. It's going to be a good opportunity to show you something. Tin. Okay. Actually, while we're here, let's do the other side. Might end up using Wagos or something to connect a cam, so don't know what I'm going to be using, but let's tin them long. So yeah, that's what you get when you learn by yourself without any real knowledge in how those stuff work. You kind of try to figure it out, test stuff, see where it goes, deduce, invent ideas, and eventually I'm gonna fix it. Probably. Hey, McShaky. Well, you're very welcome to watch while doing other things. So 5 volts is gonna be. Let's put on some flux. I'm just stupidly gonna solder directly to the pins. This and this. Hopefully this tin will melt. There we go. I have a very small iron tip, so it's good enough for testing. This one's working well, so... Oh, it's not. I thought it did. That's why. I might have to use a bigger... I have to use a bigger tip. Actually, let me add some leaded. I can lower the melting point and it's going to be easier to solder. I probably use a better tip as well, but... There we go. And this should melt. Yeah, this one is easy to melt. It's just the ground that's hard. There we go. Yellow. Yellow. Okay. Let's see if we can get a bit of a better result on the red. There we go. Okay. So now I am going to start by injecting 5 volts and see if stuff dies. So we'll go here. Clamps. 5 volts. We'll go for very little amps. Let's go 0.3. Okay, it's not drawing anything. 0.004 amps. So that's what I would expect. Nothing special. So now, if I was going to plug this back in with a ribbon cable and give it some signal here on this wire, maybe, just maybe, we might be able to see stuff in the goggles. Now that's a way to validate that all that is working. Hey, thanks Neo. Don't forget to hit the like button on the video. That helps a ton. Let's see if I can use my contraption actually. Now that contraption that already has connections for stuff. It has a connection for the camera. It has so I can power the camera from here. This can go away. This can in turn power these wires. I can just use this as a makeshift DuPont cable, DuPont wires. I could, if I just tin them a bit more, or I could just wire them. I could solder them to DuPont. Could do that quickly. To get some headers, some pin headers. Do you have some single file pin headers? I do. Gonna do it a tiny more cleanly, and just gonna solder to those. Okay, then we solder this. The order doesn't matter. Basically, just I can cut them short. Actually, let's not do this too awful. Order does not matter. There we go. Yeah, for junk connectors. Okay. Now let's get this. Take this away. Now we can use the junk, continue junking the junk. So this will receive 5 volts. This will receive ground, and this will receive signal. So now, if I'm gonna power the goggles with my PSU on 8 volt, I need a way to do 5 volts. And I have a solution for this. Hang tight for a minute. I am going to grab this. This is a charger, Rota T6, and I think this one does do PSU mode. I need a USB A to A cable. Do I have one somewhere? Do I have one somewhere? Yes, I do. I do. There we go. You always need all the types of cables. Do I sometimes use breadboards? I never remember to use breadboards. I do have some. I could do. But I don't associate them with debugging or prototyping. But yeah, I could. So does this have a PSU mode? That's the question. Let's see. 20 watt is plenty. Power supply. Yes, it has a power supply mode. And we want to output 5 volts. And we want to limit this to maybe 1 amp. 5 volts, 1 amp sounds reasonable enough for what we're trying to do. and yeah, we can start whenever. So yeah, if you have a charger, you might have a programmable thingy. So now I need a wire to have somewhere. Where did I put a bunch of I need one of those. There we go. So now we can output from our PSU. Man, the junk is absolutely real. And now we can input here. And when we turn it on, what's happening? Why did it do rebooting when I plug it in? I don't know. Maybe the wire moved. But I can now have this come out and power this, and also output the video signal for the camera. The junk is absolutely real. Now we just need to figure out a way to plug that back in the goggles in such a way that I can see the picture and confirm that the goggles work. It is the junk. So let's open this connector, plug this in. Let's give it power to check that we're not there's nothing shorted inside the cable itself, maybe. So we want power supply, 5 volt, 1 amp. Okay, it's not pulling anything, just 1 watt, which is normal for a camera. Yeah, okay. There you go. So that seems all right. We could make sure it all works by plugging in the screen on that, but I know that works. Actually, let's do it. Let's ensure everything works as expected. Nothing is getting shorted. Let's not rush. So here, we turn that on, which you see the picture for the camera when I turn on the PSU. Start task. Yep, we do. All good. That's what we want. Let's turn off the PSU. Okay, so that's good. Now we need to put that, man, it's such an absolute mess. I'm gonna need this to power the goggles. Absolute mess. This is. Okay, now we need to find a way to plug that back in this. What I'm going to do is remove the ribbon cable from here because it's easy to put in this side. And do it. I might have to pull the board out to be able to insert this, because those cables are a nightmare to put in. Maybe if I use tweezers. But let's try to grab the plastic bit that's designed to be grabbed so as to not damage the cable. Okay. Oh, I had it and then I pulled it back. Never remember what those cables are called, those ribbon cables, but they are a pain to use. Okay, I think we did do this successfully. I want to make sure, but I don't want to run the risk of damaging it. I think we're good. Let's not damage it. To push on both sides at the same time to lock it in. Okay, it's locked in. Let's never remove it again. Okay. Now this. And so now what we hope is, let's see, like this. What we hope is we get the picture from the camera in the goggles when I give it juice. Where's the juice? Where is my juice? I'm gonna turn on. Guys, I pressed the wrong thing. I'm gonna turn on this first, because this is easier. This is easier to turn. My PSU is easier to turn off. So, and let's go start a task. And this goes to 8 volts OCP. So now, supposedly, let's goggles booting. Do I have picture AV3D? I don't know what that means. So when I select AV2D, which I expect is what I want, I don't get anything. So I don't think this is working. Nothing's burning though, but just getting the signal isn't enough. Well, that's not good. Do we want to try instead with this thing, the one that supposedly works? Maybe there's a signal that needs to happen. So logically, when I press the button here, it should light up. And yeah, it does. And I need to provide it with a source of video. And I will. And now I can power the goggles and see if we get picture. Still no picture. Yeah, So it's not just the board that's dead. There's something, there's the signal's not coming in or isn't getting decoded. But AV2D isn't there. Okay, yep. Let's turn it off. Okay. So I did remove a diode from the board. It might be a very important diode. I can put it back. I'm just not sure if it does anything. It doesn't look like it would do anything important, but it very well might. So before anything else, I'll put back the component I removed. And we'll see. And we'll see. So here, and I still have the diode. I will need to clean it up, probably. I will need to clean it up, certainly, because it has some low melt solder on it. It didn't look like it was defective itself, so it still reads like a normal, a good diode. So we'll just clean it up with some wick. If I can find anything in his goddamn desk with all the things on it. I don't know. Where's my tweezers? Here. Where's my wick? I can grab some more. Where's my pliers? Here. Okay. I think, yeah. Solder on the sides. Need to wick that too. Let's see if I can get it clamped somehow in my OmniFixer. There we go. It's going to be easier. Oh, actually, I think that's all old solder. It came from the board. I'll just leave it be. Doesn't want to melt fast, so it's not some low melt, so I don't really care. I don't really care. So let's go back. Let's use a bigger let's try a knife tip for a change. So if I remember correctly from the start of the stream, it was oriented to the right from here. I will, however, just go have a quick look. Hold on a second, I'm going back on to the stream, which see if I can watch the start when I start analyzing. Make sure the diode, yeah. So yeah, it has the stripes to the right. Yep, that's what I thought. But might as well check. Let's grab some good tweezers. So not this way, but the other way. I'll put in some flux. No need for hot air in those situations. This is more than enough. And then I just go and put some solder on the other side. Okay, now if I give it, I'll give it with my, I won't do it with this, I'll do it with my regular PSU because I want to be able to cut fast. But if I give it 5 volts, does it start drawing a bunch of current? If it does, it means the thing is put on backwards. Let's go, so we want 5 volts, 0.3 amps, that's good. It's not drawing a bunch of current, so it is not backwards. I very much doubt this will do anything, but what could be doing something is not powering 5 volts to the actual pad that's supposed to have 5 volts in it. So I could try giving 5 volts to the output of the regulator where it's supposed to be generated. I'll try to do that. I'll do that. So I'll desolder it from here. And I'll go put it where it's supposed to. Where we have the RIP component. So it's here, but it's obviously supposed to be both pads. But we only care about the top part, so we'll need to grind a bit. This should be enough. Just want to make sure we don't pull too hard on it, so we don't rip the trace. But if we're careful, should be able to do this. Yes, some solder. No. Come on. Need flux. Need flux. This trace looks so big compared to what I've done recently. Can't get it more thin than that. There we go. Nice and tinned. Now we come in with our wire. Which is way too big for this, but I just need to be careful and not mess it up. Oh, sorry, can't remember. Oh, yeah, I am ripping the trace apart. Okay. Yeah, not sure it's a good idea to do that. Let's put it back on the back. I could put it on the output of the coil, which should be as good as a place as I need to put some 5 volts in. I can do that. Let's do that. It's probably better than to try and damage the trace. And to be honest, it shouldn't change too much difference, because if I remember correctly, if I go back to continuity mode, this should be continuous to this. It's not. There might be a diode in between. But yeah, this should be 5 volts. So let's see what happens when I give it. I'm guessing this is continuous to any ground. Should be. Yeah, it is. Okay. So what happens now? What happens now? Let's have a look at how much current we draw. Still the right amount. Okay, well, let's give it a go. And if that doesn't work, I'm probably gonna give it up here and start looking at videos, try to understand how it works better, and can try to go from there. Okay. Right. I want to go back to using the camera instead of the VTX, because I know this camera does emit some good video signal. And let's turn on the goggles first. 2 watts, then this. Nope, nothing. Nothing. Yep. Okay, well, that's something that needs further investigation, but I feel like to be able to figure it out, I would need some kind of donor or something similar. Do these goggles have AV in? They do not have AV in. So yeah, I think that's about as far as I can go without doing any more research, unfortunately. So what did we find? Pretty much nothing. We did find that there is a regulator that's dead, and if we try to power stuff, to bypass the regulator and power stuff, then it doesn't seem to do anything. I'm going to remove my test wires now. And yeah, that's unfortunately not a success. I think next will be, I'm going to see if I can watch some videos and learn more about how those work. But mostly, if I can find schematics or photos of what it's supposed to look like, see if I can figure out more things, see if I can find actual data sheets for the components. That way I can check if there's something that looks funky, see what those big missing components are supposed to be, whether they're supposed to be populated. So there's ones. And yeah, if I can diagnose some more. But yeah, that's unfortunate. The optics work, so that's good. The screens work. Maybe that's something that can be reverse engineered to be used with some form of AVN. Maybe, but if I could just maybe solder some tiny wires to the plug and send it video directly without going through the ribbon cable. Maybe the ribbon cable is damaged. I don't really know. But yeah, unfortunately, that's why it stops for this. And that's probably where it's going to stop for today's stream, because my desk is a complete mess, and I'm out of investigating energy for today. Very sorry we couldn't get anything better done with those. There's no obvious fail, which is what I was hoping for. But yeah, I'll keep digging at it, and I keep learning, and that's by banging my head against it for a while that I'm gonna start learning more about those, and maybe in a few months I'll be an expert at fixing Fatshark goggles. Who knows? Probably not. But yeah, thank you so much, Felix, for sending them in and trusting me not to break them further. I don't think I have. The component I removed was already burnt, so I don't think I would have. And I very much doubt installing a new one will fix stuff. Just doing that, because obviously giving it 5 volts doesn't help. But I'll keep at it. Thank you everyone for joining me on this stream. Remember to hit the like button if you enjoy this very fruitless stream, but hopefully you learned a few things. If anything, you learned that you have a power supply in your charger if you didn't know that. So not all chargers do it, but a bunch of them do. And why is it useful to you? Well, you can use it to test your flight controllers. You can use it to test your ESCs without soldering to them by banking yourself a XT62 alligator clips cable. That's super useful. That way you can make sure you can flash your ESC, make sure they all appear in Betaflight in the digital telemetry. So if it fails, if it doesn't work, then you can just send it back, and they won't hassle you. It's much easier to send stuff back if you haven't soldered to it. Shops don't really make any difficulties. Especially if you send them a photo where you test it with a PSU and it's not soldered, it doesn't work, then you can just send it back, and that won't be annoying at least in my experience. So yeah, it's super useful to have a small benchtop PSU. So yeah, if anything, you might have learned that. I will see you next week for the last stream before a bit, because I'm gonna go on holiday, on a couple of holidays. So next week, not sure what we're gonna do. What we're gonna be looking at, probably fixing the 2 AIOs by soldering the components that I have or will have received. And then I don't know, maybe I'll find something interesting to repair, and then I'm gonna be off for 2 weeks. Thank you very much for joining. I will see you next week. In the meantime, have a good one. See you next time. Bye.